All right, welcome everyone. Really appreciate you joining today. Again, my name is Michael Banta. I am the VP of Product here at Cloud Institute. Now, to give you a little background real quick, Cloud Institute is a coaching and training company that helps IT professionals and teams at companies to learn new skills and earn cloud certifications. And we believe training is only successful if the skills you learn in the classroom actually transfer to the workplace and help you achieve your goals. And that's why all of our training products include access to personalized one-on-one coaching with cloud experts. Today, we're giving away one Google Cloud Certification Bootcamp pass, which includes 34 hours of self-paced training and 2 hours of that personalized one-on-one coaching with a cloud expert to prepare you to earn the Associate Cloud Engineer and Professional Cloud Architect certifications from Google Cloud. This is a $500 value, and we're giving it away for free. If you're interested, drop a comment or a question in the chat, or send me a message in the chat or on LinkedIn, and you'll be entered to win. Now, today we're presenting day 2 of a crash course to prepare you for the Google Cloud Associate Cloud Engineer certification exam with Prerit Munjal. If you missed part 1 yesterday, you'll be able to find a recording of that session posted on whichever channel you're watching this now, regardless if it's Facebook, YouTube, or LinkedIn. Additionally, if you'd like a copy of the presentation, please send me your email on LinkedIn or enter your email in the chat, and we will send the presentation to you. Now, a little background about one of our cloud experts, Prerit, who is presenting today. He is a Google Cloud Platform architect, developer, trainer, and consultant. He has 8 Google Cloud certifications, as well as 14 Microsoft Azure certifications. So he has tons of firsthand experience with certification exam preparation and testing. We're thrilled to have him here to share his knowledge on how to earn the Google Cloud Associate Cloud Engineer certification. It's very popular, very in demand, so please listen in and we will get you prepared in today's part 2 session. So Prerit, I will turn it over to you.
Thank you, Michael, for the great introduction. Now, I will be presenting for today's agenda. Most of you, I think most of you are joining on day 2. If you have not attended day 1, please have a look over there. We have already provided the uh, recordings of that agenda. So, day 1 agenda was all the infrastructure part, all the computational things, all the computational services provided by Google Cloud like GKE. We discovered about Google Compute Engine. We discovered about the networking part, virtual private cloud, what are firewall rules, how to make a system more secure. We discussed about Cloud Armor as well. For today, I have reserved this session for data part because Associate Cloud Engineer is the certification that is in real high demand, and also it is one of the toughest associate certification in the market right now. And also, companies have made it. Some companies have made it mandatory to have the people this certification so that they can apply for some cloud consultant role or some sort of cloud architect role. So yeah, this certification is really your stepping stone into Google Cloud. Today's agenda is data. I will be discovering about everything about data services in Google Cloud. And also at the end, I will be demonstrating a hands-on experience. I will be deploying a WordPress website and integrating it with the Cloud SQL instance. Along with this, I will also teach you how the BigQuery part. I will create some federated queries. I will teach you what are those queries in the later section. And also, it will be a lot of fun. Just hear me out for the next 30 to 45 minutes. So what is data? Why data is included in this beginner certification? So every company as of now is a data company, whether it's Google, Microsoft, AWS, or Amazon, Mintra, or any shopping website, or Airbnb. Every company is a data company. They like to collect your data, then perform some analysis, some, so that they can, not for the bad influential part, but for their own personal use cases, so that they can handle the user request more efficiently, so that they do not over provision their resources. They can predict what is the peak usage are when the user is more active, so that they can give more optimization to their internal infrastructure, as well as give you a very very good experience on their platform. So every company is a data company. What are asset properties, and why data on cloud, why we are talking about it? So previously, if somebody has to store some data on their on premise, they used to pre-provision those resources. Like for example, you have hard drives, you have SSDs. So in order to use that, you have to order them for your personal use case. For example, your memory, or your laptop is running out of memory, so you have to pre-provision it, order it from Amazon, and then attach to your laptop. Similarly, in the production grade environments, we have big memory chunks, we have big memory racks, and we need to pre-provision them, we need to buy them. So that is called as capex. Capex is capital expenditure. So companies previously, before cloud came into the picture, companies used to spend highly on capex. And also, by the time memory gets degraded, your RAM gets, like the efficiency of your RAM, or your data storage, any data part gets degraded by the time. So when the cloud came, Google Cloud, Amazon, AWS or Azure, all the cloud vendors, whether it's Oracle or IBM as well, they have provided computational and data resources on pay-as-you-go model. Like there's no need for you to pre-provision them. You just pay for the memory used, and also if there is some computational power involved, like BigQuery. So in that case, you just need to pay for your use case. No need for any capex, just opex. Now, what is the asset properties? Later on, I will discuss these properties, because now I am touching the high level overview of what is data and why data is stored on cloud. Now comes the part of what are types of data, right? Because everything in our environment is segregated into something, right? So broadly speaking, our data is categorized into three parts. One is unstructured data, it is also known as raw data. Second is the structured data, which is not very user friendly. The second thing is semi structured data. So let me give you a very realistic approach of what these data types are. The first one is unstructured data. You use WhatsApp, right? You use Snapchat. So everything you use over WhatsApp, for example, your call logs, for example, your uh, pictures you send, for example, your videos, everything is included in your unstructured data. Any data can be unstructured. For example, your CSV file, your Excel file, your presentations, your decks, your slides, everything can be included in unstructured data. Why we are segregating our data? Because in cloud we have to find a particular service for a particular type of data. Later on, you will find 6 to 7 services that are required for this certification. Though Google Cloud offers more than 25 services for data as well, for CDC, for data streaming, for cleaning the data, for visualizing the data. But for this certification, we need only 6 to 7 services. First one I told you about the data part. First is the unstructured data. Nearly 80% of the data that we use in our life belongs to this type of data. Second thing is structured data. Structured data are those which follow a particular schema. A best example of particular schema in real day life is your tables. Like in the deck, you can see that there is a table with the columns as first name, last name, address, city, age. So all the schema is fixed by us before. For example, we give a form to the user, so user has to fill these things, unless the form would not be uploaded to us or would not be submitted to us. So the schema is fixed. User has no options to disable it or enter null values. So on high level overview, this is about structured data, that the schema is fixed and it is in tabular form. The second type of data is semi-structured data. Semi-structured data is a mix of structured and unstructured data. For example, it is not totally raw, and it does not follow that particular schema. There is no hard and fast rule that this type of data will be having a fixed schema, or this will be having a fixed table. No, nothing. This is a high level overview of semi-structured data. Most common example of semi-structured data is IoT sensors. We have Alexa at home. We have all the IoT things at home. For example, we have a ultrasonic sensor. So all these type of sensors involve semi-structured data. Why semi-structured data? Because every sensor can't export same type of data. For example, one sensor just needs your distance. Some sensors need only your temperature. So every sensor has a different use case. Every sensor has a different demand, and so this is the main reason that they use semi-structured data. Now, before jumping into the services, what are the factors to decide which data service? First thing first, we have discovered the type of data. For example, you can face a question in the Associate Cloud Engineer certification that pick the type of the you we the current company is going to upload petabytes of pictures across their on-prem to cloud. So please label it as which type of data it is. First option will be semi-structured, second will be structured, third will be raw, fourth will be none of these. So you just have to pick the unstructured data. And the first part is done. We have discovered what is type of data. Second is the type of workload. Broadly classifying all our workloads on cloud or online thing, there is only two type of workload. One is OLTP, second is OLAP. OLTP is online transactional processing. OLAP is online analytical processing. So these have very very good distinction between them. By the term OLTP, transactional, that means in uh, bro- like on high level overview, everything is a transaction on internet. There is no thing like we are performing a credit or debit from our account, that is a particular transaction. Everything on internet is a transaction. So may it be some buying your stuff, may it be ordering your stuff, that everything is covered under transactional. Second thing is OLAP. OLAP is online analytical processing. So this is majorly used for example, you have a particular petabytes of data from a company, from your user base. You need to analyze the peak number of hours. You need to analyze what is the downtime. You need to calculate what were the SLAs for you for the previous month. How much downtime did you achieve? How much uptime did you achieve? So for that part, we use OLAP things. Third thing, the amount of ingested data. This is the very very crucial example, a crucial point, because there are various tools. If you talk about the amount of ingested data, talking about three services from for transferring your data from on-prem to Google Cloud. We have three services for data transfer on basis of this Associate Cloud Engineer. Though we have other services like data stream, but for now we have three services. One is GSUtil. GSUtil is a service that is used to transfer or download your data into your buckets. GSUtil was just made or built for the cloud storage part. Cloud storage is a service that supports unstructured data. I will be teaching you in the later stage. Second thing, second service that supports the transfer from on-prem to cloud is the cloud data transfer service. Third is the transfer appliance. So all these services are totally dependent on the amount of data you are transferring. For example, if the data is less than 1 TB, we will use GS util. If the data is more than or less than 10 TB, we will use the storage transfer service. If the data is in petabytes, it's in 100 petabytes, then we will use cloud transfer appliance. This was about the third point, amount of ingested data. Fourth is the network footprint and the consistency, because there are companies that cannot invest that much, but they want a particular availability of their service. For example, you have, there are services in Google Cloud that are, some are regional and some are global. So it totally depends on your use case, the network footprint you want to remain regional to your the users, or you want to go global and reach wider audience. Also, consistency comes with the network footprint as well. I will be discussing all the points as per the services. Now, the first service that you need to be very careful about is Cloud SQL. Cloud SQL is a relational and OLTP workload database. What is relational? Again, relational is a term used for structured data. If you have some structured data, for example, you want to perform some online transactions, or you want the user to fill the feedback form, or the feedback form that all the options are necessary or compulsory, they have asterisk in front of them. So for this purpose, we can use Cloud SQL instance, and it is a OLTP workload. So in exam, if you see any term like relational, structured, OLTP workload, and you have to perform transactions, so you just have to pick Cloud SQL and span. There are two services for the OLTP workload. Currently, we are on Cloud SQL. So Cloud SQL, to be noted, it is a regional service. What is a regional service? Actually, the entire globe is divided by Google Cloud into particular regions and zones, as per their criteria. They have only divided it. For example, in US, the states is divided into US Central one, US West one, and all other regions. Similarly, India is divided into Asia Southeast one and others regions. So the Cloud SQL service is regional by default. Why it is regional by default? Actually, they just created because some users need to have need to be regional to their user base, so they created this service as regional. And it supports 99.95% of availability. This is the consistency that Cloud SQL provides. You need to learn it or cram this number, because you will be facing this in the question paper, uh, the consistency and the regional part. Second thing, what more features about Cloud SQL? So Cloud SQL was recently launched by a new feature was launched, namely HA. HA is termed for high availability. For example, there is some disaster, or there is some downtime in the data center. So uh, by enabling the HA feature of Cloud SQL, your data will be directly replicated to one of the other instance in another region or another zone. Depending on you, you have to define it, or you can create read replicas. Generally, to diversify our load, we create number of read replicas and make write to only one database, and they are synchronously updated. The read replicas are synchronously updated from the master node. So you can also create read replicas in multiple zones. For example, if you face any sort of disaster, or there is some fail, you have to perform a failover, so you need to have a read replica, so that your data isn't entirely lost, and you can create that you can promote that read replica to master node, and again create a read replica of that master node in another region. By this, you can achieve high availability, and also ensure that your data isn't lost in any type of natural or some data center failures. The third thing is recently Cloud SQL also introduced deletion protection. It was made like if your employee or due to some manual or automated error, your database doesn't get deleted, because it was observed that users mistakenly deleted their database or Cloud SQL instance and lost their entire data, and they didn't even have the read replica, so entire data was lost. So for this thing, um because databases and the data part is used by nearly 95% of the companies in Google Cloud, they need to store the data. For that part, they introduce deletion protection. In case of accidental deletion, this Cloud SQL instance won't be deleted mistakenly. The last thing is what the Cloud SQL instance, you can create it privately as well as publicly. So if you want to make it your use case, or you want to put it behind a load balancer so that your public IP is not exposed to the outer world, or if you want to expose your Cloud SQL to the outer world directly, you can share it in both ways. You can create it as private or as a public instance. Now, Cloud SQL supports three type of database engine. First is MySQL, that is used majorly by all the companies. Three versions are supported in MySQL. One is 5.6, 5.7, and 5.8, 5.9. And also another database engine that is supported by Cloud SQL is Postgres. That is also used by most of the companies. And the last one is SQL Server. There's no need for you to go deep dive into what are these, or what should I pick. uh, they are basically built for the personalized use cases. Some companies prefer Postgres, some company prefers MySQL, some are on SQL Server. So to give wider options to their customer base, they have created all these options. And this was about Cloud SQL. If you face any questions like OLTP, relational workload, and transactions, a regional resource, and you need consistency of 99.95%, just pick Cloud SQL. The second was the second option that we get for data and relational thing is Cloud Spanner. Cloud Spanner works similar to Cloud SQL. They have nearly no difference. The only difference that, like, they have a good difference in their working in their internal structures, but on high level overview, the only difference between them is that Cloud Spanner is global by nature, and it offers way more availability and SLA than Cloud SQL. It works similar. It works with relational database. It works for OLTP type of workload, and also it is the only difference is that it is global by nature. Global by nature means the spanner is distributed among all the instances in entire globe, so there is no need for you to configure that I need spanner in this particular region, I need spanner in Australia, I need spanner database in the US Central. So there is no need for you to define it. Cloud Spanner automatically distribute data among all the instances present across the globe, and it offers a service level agreement of 99.99%. That is five nines, and which is near to 5 minutes of downtime in the entire year. That is really really massive as compared to the competitors, as compared to the other cloud vendors. Other Another features that are supported by Spanner is automatic sharding. Like sharding, I the it Cloud Spanner was built on automatic sharding because it distributes the data across multiple databases. It distributes everything. And second is point in time recovery. No need to go that much deep, but point in time recovery, by the name you can guess that if you want to recover from a disaster, you can recover it in a very minimal time or very minimal downtime. The second is real data capture, again out of the scope of this certification, but if you see any sort of things like OLTP workload, relational, global, and 99.99% of SLA, then pick Cloud Spanner. We are only two services are there for relational databases, that are Cloud SQL and Cloud Spanner. The next thing, we are shifting to semi-structured data or NoSQL. NoSQL. Uh, NoSQL means no structured query language, and there are two services that offers this type of data storage. One is Firestore, and second is Bigtable. Coming back to Firestore, Firestore is offered in two modes. One is native mode, and second is data store mode. So why to use Firestore? Firestore was why there are two modes in Firestore. Let me come to that question first. Previously, Firestore was not Firestore; it was named Data Store. And like by the time Google realized there is a need for another type of database, so they introduced native mode as well. A point to be noted here: if you pick native mode or data store mode, you won't be able to go back and change the type of mode. So you have to be very very certain while selecting a particular mode. And also you can expect 1 to 2 questions on this topic in your certification exam. So it is the difference is pretty much common. If you want some mobile or web support or library support, then just pick native mode, else you need to pick data store mode. For most of the things we use native mode only. So this was about Firestore. It is very much less used in this certification because you will be dealing with more relational data. And this was about Firestore. The next big thing is Bigtable. Bigtable is you will is the very very much used service by the cloud customers. So it is a NoSQL wide column database. The term here used is wide column. What are wide columns? So, and why it is used with wide columns? Why can't it be NoSQL column database? Why it is wide column database? So wide column databases are majorly used for high writes, low latency writes, and for example, you have incoming writes of thousands in 1 second. So thousand writes per second. So for that purpose, we use wide column databases. To know more about wide column databases, you just need to read the white paper released by Google. So have a look over there. But Bigtable was made just for IoT sensors only. Specifically, majorly or specifically, it was made for IoT sensors, and it is ideal for low latency writes. You are having like 10,000 writes per second. Bigtable will handle it. So if you face any questions in data in the certification exam, like you need IoT sensors, you have incoming IoT sensor data, you need wide column database, you need very very less latency, right? Just pick the Bigtable service because Bigtable was built for this type of data. AdTech data, IoT, and FinTech are the most common use case because here writes are at max. Because if you are using some app, for example Google Pay or Amazon Pay, so they have multiple transactions within a second. So Bigtable was the service built for this purpose only with low latency, writes. Now we are pretty much done with the structured SQL data and NoSQL data. Now comes the next big thing, that is BigQuery. 90% of the users just come to Google Cloud for using BigQuery. Why BigQuery? What is the advantage of BigQuery? Let's discuss that. BigQuery is a OLAP service provided by Google Cloud. OLAP is online analytical processing. By analysis you can think that you have to run queries, you have to derive data, the meaning out of your data will be given you, schema will be given to you, you just have to derive data out of it. Why BigQuery is so fast? Actually BigQuery uses multiple things behind the hood. It uses Colossus file system, it uses Borg and Omega uh, as the computational power, because you need to have computational power to run queries, right? You are deriving some data out of your you are deriving some meaning out of your data, so you need to have some computational power along with the data part. So BigQuery is a very good combination of computational and data part inside a particular service. For your knowledge, it uses Colossus file system behind the hood and Borg and Omega, which are ancestors of Kubernetes. Uh, BigQuery uses that under the hood. So BigQuery is very fast. You can analyze petabytes of data within minutes. Before BigQuery, you need to wait for at least 1 to 2 hours. And also, now coming to more technical stuff, what are data sets, what are tables, what is clustering, what is partitioning, what are views, what are federated queries. So data sets, basically, data sets you can imagine as a folder where all your tables will be stored. Tables are nothing, tables are your data. uh, because you need to query data, you need to have a schema for a table. So all your data will be stored in your table. The most common example of a table will be your CSV file or your Google Sheets. So you have a table over there, right? You need to maintain that table. So tables are that thing only. Data set is a folder for your particular tables. And this is about data set and tables. The next very big thing that BigQuery supports is the clustering and partitioning. What is partitioning? It is majorly used for high ingress data. If you want to segregate data based on time, based on integer range value, based on month of the date, month, date, or year. So it is used for that part. Why partitioning and clustering? Basically, these two two methods are used for improving your efficiency in running the queries. Your The query is very much efficient if you implement partitioning and clustering, because you have to scan the particular data. You don't have to scan the entire data set, entire table. You just have to scan a particular part of a particular chunk of the data. So your your scanning time will be less. And also, one important thing about BigQuery is that BigQuery charges you for the number or for the storage as well as the computational power. So if you are storing 10, if you are running a query on a particular table, so BigQuery will charge you on the storage of that particular table, and also the bytes scanned. Before even running the query, I will show you in the demo that it will show that this much bytes will be read or this much bytes will be scanned during this process, during this transaction. So BigQuery charges you on that. Coming back to partitioning and clustering significantly reduces your cost to analyze the data. Partitioning is used for dividing or segmenting your data as per your partitions defined. It may be date, may be time, and may it be hour, may it be a particular integer value. Clustering is another very good thing, a very advanced technique. Partitioning is still used by most of the developers, but clustering is one more advanced technique. You divide the database into multiple chunks of tables and then store it elsewhere. There's no need for you to go that much deep into partitioning and clustering, but these are the two methods that helps you in performing your query efficiency of the queries. The next things are views and federated queries. Federated queries are something if you want to export your data to BigQuery for analysis in near real time. I will be performing federated queries in the later section, from Cloud SQL to BigQuery. The only use case is that if you want to analyze your data in near real time, so you can use federated queries. Saved views. Views are There are generally three types of views. One is authorized views, materialized views, and views. So shared views. So views are nothing if you want to save that particular query, or you want to share that particular query with other users for some analysis, or may it be audit purpose. You can use views. It is of three types: authorized, materialized, and shared views. Now we have covered OLAP and OLTP workload. Uh, for OLTP, we have covered Cloud SQL, Cloud Spanner. For OLAP, we have covered BigQuery. Now the biggest uh, biggest weightage of data service in this certification is cloud storage. Cloud storage is for object storage. Objects are nothing. You can term any of your data as object. Your CSV file can be an object, your photo can be an object, everything can be an object. So cloud storage is the only service that supports object storage in Google Cloud. Object storage, by the name, is that you can store any data, anything can be stored as per your convenience. So in cloud storage we have buckets. So what are buckets? Buckets are similar to your buckets that we use in our restrooms. Generally we have buckets. So buckets are used to store water, may it be warm water or cold water depending on your choice. Water can be anything. Similarly we have buckets can store any type of data, just similar to your buckets in the real life. So you just need to define that what is the storage class of that particular bucket, and also made it can be regional or multi-regional or dual regional. So you can because Google needs to know that where your data must be stored, right? If you want your regional, then you have to define that please store this data in a particular region. If you want your data to be stored in dual regional, you then have to tell the Google. So this was about the regional part. Now coming to the storage classes, there are currently five types of storage classes. One is standard, second is nearline, third is cold line, fourth is archive, and fifth is auto class. So what is standard? Standard is used for your daily purpose. If you want to access your objects once in every day, or you just have to access your objects daily, you don't want any restrictions on the access of your objects, just pick standard. Standard is picked by default. Second is nearline. If you want to access your object once in a month, or you very less frequently you access your objects, then pick up nearline. Third is cold line. Cold line is used when you want to access your objects once in a quarter or 3 months. Why someone would access their objects once in a quarter? The reason behind is that in every quarter we have some audits, so we may have some huge data for logs, or some data for the data activity, data access logs. Any type of audit can happen once in a quarter. So for that reason we can use cold line. The last one is archive. If you don't use your objects for more than 365 days, or once in 365 days, then you can pick archive. The main reason for you to define storage class is that the you will be charged differently. For standard the prices are much high, for nearline it's pretty much low. So the entire idea for you defining the storage class is to save money, because like for 10 GB of data you won't be facing any issues, but if the data is in petabytes, it's very huge, so you will be charged more, right? And the fifth class is auto class. This class is introduced in this year only, so there is no need for you to define any class like standard, nearline, cold line, archive. Google just pick auto class, and Google Cloud will automatically sense or segment your data into particular class. This was about storage classes. Next thing is what are life cycle policy, what are retention policy, and bucket locks. A very important topic for this certification. Life cycle policy are used when, for example, you are working in a company and you want your data to be transferred to from standard to archive after 30 days, because that data won't be used further, and you just want to have a copy for maybe some future use case, but there's not that much use as of now of the data. So you can define that in lifecycle policy, that after 30 days please pass my data from standard to archive. One thing to make a note here, you can always degrade your storage class. That means you can't go from archive to standard. First line is standard, nearline, cold line, archive. You always can come down, but you can't go upwards. So this was about lifecycle policy. Now comes retention policy. Again, to save you from mischievous activities or maybe some accidental deletion, retention policies were made, bucket locks were made. So bucket locks prevent your object from accidental deletion or if you are certain that you will be storing this particular object for next 3 years, for next 1 year, for next 6 months, so you can put bucket logs on that. This was about lifecycle policy and retention policy. Now comes ACL. What is ACL? Generally, we know the term about IAM. I taught it yesterday. What is IAM? Identity and access management. That is more for uniform approach. Um, IAM is for your entire project. But what to do when you want to give access to a particular object, or you don't want to give the access to a particular object? For that term, we use ACLs. ACLs are access control lists, and they are used for granular approach. And you can define the scope of that object on very granular level. For example, you just want that viewer to view, or that or you want all authenticated users, you want all users, or you want a particular user just to view it, and not download it, or other stuff. Or you may even not want that particular user to view that particular object. For this purpose, ACLs are used. Other storage options, I taught it previously also. What is transfer appliance, data transfer, and cloud, and GS util. If your data is less than 1 TB, or then you can use GS util to transfer the data. But if your data is much more than 1 TB and less than 10 TB, you can use cloud transfer service. And if your data is really huge, you have petabytes of data, then you have to raise a ticket to Google Cloud team. They will send you a physical box of data storage to you. You need to connect your wires to it and send data over it, and ship back the appliance to Google Cloud. Google Cloud will safely handle it with their encryption keys, and transfer the data to their data center that you have told them to transfer to. This was about cloud storage. Please give more emphasis on cloud storage, because most of the questions will be from cloud storage only. 50 eh, Talking about the data part, so 25% of the questions will be from cloud storage. Next, we are pretty much done with what our storage part. Now comes the miscellaneous services. What is Dataproc, Dataflow, and other services? So Dataproc, you just need to remember that this service is made for Apache Spark and Hadoop cluster workloads. Uh, the best use case that you will find on labs and other thing is to calculate the value of pi. So you can calculate the value of pi using Dataproc cluster. You just need to create a cluster, and it will handle everything for you. It will auto scale, and the major advantage of using this service is that usually Apache Hadoop and Spark cluster were difficult to maintain and create, and also they required huge resources. For this purpose, Dataproc was introduced, and you just have to pay for the resources that you have created. A simple thing: if you face any question like Apache Spark or Hadoop cluster workload, or you have to, your previous company is using Apache Spark and you are looking an alternate in Google Cloud, then you can pick Dataproc. The next service is Dataflow. Dataflow was built using Apache Beam, and the best use case for Dataflow is the pipelines. For example, you want to send your data from cloud storage to BigQuery, then you can create a pipeline using Dataflow. You can ingest the source. So you can enter the source as cloud storage, specify the bucket, specify the objects, and transfer that to BigQuery by specifying the destination as the datasets and tables. That's it. If you want to build custom pipelines, you can do that as well. But Google Cloud also provides you predefined templates. By using them, you can create pipelines, and it is built on Apache Beam. So you if you find any questions in the exam like Apache Beam, and you are looking for pipelines, so you can pick Dataflow as well. Now, uh, we will be giving you this presentation. So it is a quick recap for all the storage type. Relational, we have SQL, Spanner. For NoSQL, we have Firestore, Bigtable, Analytics, we have BigQuery. Object, we have cloud storage. Block, persistent disk, we have talked it yesterday. And file store, again, not very much used in this certification, but if you need to have a proper file management tool, a file management service in Google Cloud, just pick for Firestore. And file store, not Firestore. And if you are looking for some in-memory databases, you are looking for some caching service, you can pick up memory store. Again, no need to go that much deep. Memory store is the service offered by Google Cloud for in-memory database, and it is offered in two services. One is Redis cache, and second is memcached. And this was about storage types. So this is a simple um, data flow diagram for picking the service. Pretty much basic one that we have covered it before. The we are nearly done with the computational and data part. Some questions you can expect on compliance and regulations. So generally, we have four compliance that is taught under this certification. One is the EU GDPR, second is the COPA one, third is HIPAA, and fourth is PCI DSS. So what is this compliance? In the European Union has defined their particular laws for data retention and data for storing the data along with the EU. So for that reason, they have GDPR. There is no need for you to go that much deep. Just have a high level overview that EU has GDPR. They have defined their own compliances, and for EU customers, Google Cloud has to follow GDPR compliance. Second is the COPA. COPA is for child protection, and it was established by US. And Google Cloud is nearly 95% of the services are compliant with these all the regulations. HIPAA is for health insurance. Fourth is PCI DSS, that is ensured by all of your online processing data, online payment processing apps, may it be Google Pay, may it be Amazon Pay. If you just launch it now, you will see somewhere written PCI DSS compliant. This was about compliance and regulations. Four are generally made, but there are multiple, and not all the services are compliant to these four compliances. Some are not. I think Dataflow is not compliant to one or two compliances as of now. Now, talking about the exam, what could go possibly wrong during the exam? First is system crash. Your system can crash, like your Windows can crash. So there no need to panic in any of the scenarios. Just reboot it and go to the support that I have mentioned in the option. We will be sharing PPT with you guys, so don't worry. So go to this link and tell them that your system crashed. They will surely help you. Second is odd video audio feed interrupted. For this, just delete your antivirus system in your systems, as well as disable your firewall rules. This meant because at the backend they will the software that you will be downloading for this certification, they need to have your access to your camera as well as your microphone. So firewall can disturb the access. For this reason, just disable the firewall rule. Third is eye movement caught. So please look into the screen. Don't look here and there. AI and Proctor can catch you for this purpose. Fourth is unauthorized material found. So make sure that your phones and Apple watches are out of your reach. Now let's implement. So this is the Cloud Console. I have already created a virtual instance. So there's no uh, hard thing to create the VM instance. Just go to the VM instance thing. Just type VM instance in the header, and you will be landed to this page. Uh, I think my system is okay. Yeah. So you just need to type cloud compute engine. Yeah, so you need just create one. I have already created it and installed Apache 2 and PHP over there. You just need to give it a name, pick a region, because Google Cloud needs to know where to reserve your IP and where to reserve your VM instance, your data, your boot disk, your persistent disk. Now enter the machine configuration. For this tutorial, I have used N1 standard one. then you need, everything will be common. Just you need to go under advanced options, and under management you need to have a startup script. I've already created one. I've installed Apache 2 and a PHP in it. So after that, after 1 to 2 minutes, your compute engine will be created. Now we have, I've already installed WordPress on it. So you just need to ping the external IP, just enter it, and it will be like this. Now we need to connect it with a Cloud SQL instance. I have already created a Cloud SQL instance in the backend because it takes around 5 to 6 minutes for instance to be created. So I have created it already. You just need to pick which database engine you want: Postgres, MySQL, SQL Server. Go to the particular option. For this tutorial, I will be using MySQL. Enter the instance ID, enter the password. May, to be sure that this is a password for the root user. Root is the user that is already created by default. You just need to give your password. Choose the database version, and fill all the necessary things, like for which thing you are building, development or production. Pick the region, specify the zones, and under configuration option you can pick machine type. I have used lightweight because there is not that much computational power needed. It is near about N1 standard one. And you need to pick the storage type, connections. One thing that you need to make sure that while mentioning the network, you need to paste the external IP address of of the compute engine, because by default all the access or all the traffic to your SQL instance is blocked. So you need to specify which network is allowed, which like here also you are specifying what is authorized network. So you need to define CIDR ranges to allow IP addresses in those ranges to access your instance, because every traffic is blocked by default. So you need to define the IP address of your VM instance on which we have deployed WordPress website to access the databases, to access your SQL instance, because in SQL instance we will be creating databases. So after defining the network, data protection, you can have the enabled. You need to disable this because we will be deleting this afterwards. And if you won't deselect it, you won't be able to delete this database. Now, after creating it, it will take around 5 to 6 minutes. You can't use SQL instance directly. You need to create databases. Go under databases section and create a database from here. Just name it, uh, make the character set as UTF-8 and click on create. I already created a database with the name first underscore DB, and we will be using this database for our use case. And under users, you can add multiple user account. You can give access to multiple users. For this tutorial, I will be using only the root thing, and the password that I provided before. Under connections, you can edit it. You can add network, like you can attach more VM instance to this SQL instance. And under replicas, you can define where to create read replicas. Again, read replicas are used to distribute your load to your entire SQL instance, and also for the uh, failover part or disaster recovery. Again, disaster recovery is of three type: cold, warm, and hot. So not don't go that much deep. Just have a fair view of understanding that there is disaster recovery. Disaster is something that if some natural calamity hit your data centers will go down. For that part, we need to create a recovery if our data centers go under the disaster mode. And this was about SQL instance. I have already created the instance. I've already created a database. We have already the user. You just need to ping this particular external IP of your VM, and this will be done. You will be able to see Hello World Cloud Institute, because I provided the name over there. And you can over it. You can make a post. You can add new. You can do anything like you would have done in WordPress website. Now we need to connect to it. We need to connect to our database. For this thing, we will be connecting to our database using the SQL, using the CLI tool. So the Cloud SQL Connect. Now we need to enter the name of our SQL instance, that is Cloud SQL hyphen SQL instance. Then we need to provide it who we are. So for this, we are user root. Now click on authorize, and after authorizing, it will allocate you 5 minutes to connect. Like for the next 5 minutes, it will allow all the incoming traffic. After 5 minutes, it will be again disabled. You need to run this command again. So it will be working in 1 minute. Uh, and after that, you need to provide a password. And also, I will be showing you what we have stored in our database, right? We already connected this database to our compute engine or the WordPress website. This is the first underscore db. So let's see what's is inside our first db. I will be entering a password. You won't be able to see the password because the basically next thing. Now we have successfully logged into our Cloud SQL instance. Let me just switch to uh, the our first database. The name was first db. We will use simple keywords like use first db semicolon, and you will be able to see all you will be able to see the status change to database change. Now we will be seeing what is under our database, what are the tables created by WordPress in our database. So just need to enter I think some, yeah, tables. So you need to enter show tables, and these are all the tables created by WordPress website inside your database. WP comment meta, one is option post meta. So this is about your SQL instance. Now what I have done is I have connected this SQL with BigQuery. By we have created a federated queries. We will be running the federated queries. So you just need to click on add data, connections to external data sources. Add the connection ID as anything, may it be your name. Now the Cloud SQL instance, you need to go back to your database. You need to go under overview. Then you need to copy this thing, your connection name, paste it over here, and you need to give a database name. Here we use the database as first underscore db. Give the username as root and the password. Now the connection will be created. I have already created a connection similar. Now in order to query it, just click on query, and select star underscore wp users. For example, the first db is the database that we were using. Wp underscore users is the table. For example, we want to use some other table for us. May it be wp underscore user meta. So for this thing, just enter this, just change uh, data the table thing, and user meta. I told you, right, before even hitting the run query, we have it showing that you will be processing 0 bytes when you run. That means we will be built for free. Now after running, clicking on run, this is the things that we have got already created by WordPress. Meta keys, nickname, admin color. Similarly, you can run queries for multiple links, like for comments we don't have as of now, so we won't be getting any return in that. So you can have federated queries, you can have real time analysis of your data. So this was about the uh, thing about the tutorial and the end of this crash course. Now some time for question answers. Yep.
There we go. Prerit, can you hear me?
Yeah, Michael, perfect.
All right, wonderful. I apologize. For some reason, I'm having trouble with my video. Yeah, that's too bad. All right, wonderful. Well, thank you so much, Prerit. Again, the demos were fantastic. The presentation was great. I know this was certainly a lot of value once again. So greatly appreciate everyone attending. Now, we certainly are able to take some questions if anybody has any. And I don't see any in the chat. So if anyone does have any questions, feel free to enter them in the chat. Otherwise, if there aren't any questions, we can certainly wrap up, which is fine. Just a reminder to those who are still here and listening, if you'd like to receive a notification when we release a new Google Cloud training product, if you want to be set up with a cloud certification coach to help you pass one of these Google Cloud certification exams, we can certainly set you up with an expert. And all you got to do is send me a message on LinkedIn. You can also enter it in the chat here. We'll keep it up for another minute or so. You'll also be able to you'll also be entered into win a free pass to one of our really popular products, which is our Google Cloud Certification Bootcamp, which guarantees that you pass 2 of the most popular Google Cloud certifications, the Associate Cloud Engineer, which Prerit helped us with today. And also we have courses, labs, and coaches to help you not only pass the Associate Cloud Engineer exam, but also the Professional Architect certification exam for Google Cloud. So definitely reach out to us if you want any more information, if you want to be entered in to win that boot camp. We'd love to have you as part of those entries. But otherwise, I don't see any additional questions in the chat, but definitely reach out to us, Cloud Institute, on LinkedIn, YouTube, Facebook, wherever you feel comfortable, or even visit our website at cloudinstitute.io, and we'll be happy to help you with any of your certification goals. All right. Well, thank you, everyone. Hope you have a wonderful day. Thanks again, Prerit.